Question 3 of this exercise is an interesting question based on the question 1 of the same exercise. Here's what the problem statement says. In a huge park, people are concentrated at 3 points. Point A, where there are different slides and swings for children. So this is point A here. Then point B, which is a man-made lake. So this is point B. And point C, which is near to a large parking and exit. So this is point C. So, and we are told that people are concentrated around these 3 points. Now the problem says, where should an ice cream parlor be set up so that maximum number of persons can approach it? So what this problem basically means is that where should an ice cream parlor be situated so that people can, the maximum number of people can approach the parlor easily, which means shortest distance possible. And that basically translates to the solution direction, which is also given as a hint here. The parlor should be equidistant from A, B and C. Why? Because if we have the parlor that is much nearer to one point than the other 2 points, so let's say if we put the parlor somewhere here, which is very close to A but quite far off from B and C, then people located at the points B and C will find it difficult to walk up to this point, right? Similarly, if you put the parlor here very near to B, then people from A and C will find it difficult to come here, and so on. But what if you found a point somewhere here, let's say, that is at the same distance from A, B and C? So all the people will then find it quite easy to walk up to this parlor. So basically the problem reduces to finding a point that is equidistant or at the same distance from A, B and C. So let's do that now. So in this figure here, I have zoomed up the A, B, C, the points A, B, C. And what we are going to use is basically the idea of question 1 of this exercise, finding a point that is equidistant from 3 points. And how did we do that? Well, if you want to refer to it again, you can go back to that video. But the essential idea is that we take any 2 sides of the triangle formed by these 3 vertices, these 3 points. So here I've taken AB and BC. Now we draw the perpendicular bisector of both of these segments. So if I draw the perpendicular bisector of AB, let's say I get a line like this, which is the perpendicular bisector of AB. So it bisects AB and it is perpendicular to AB. And now let's draw the perpendicular bisector of BC. So something like this. And this is the second line bisects BC and it is also perpendicular to BC. Now why did we do this? Well, because if we take any point on the first perpendicular bisector, let's say any point on this line, on this first line, it will be at the same distance from A and B, because this line is the perpendicular bisector of AB. Similarly, if I take any point on the second line, on the second perpendicular bisector, so let's take this point here, this will be at the same distance from B and C because it lies on the perpendicular bisector of BC. And this means that if I take the point that is on both perpendicular bisectors, which is just one point, this point here, the intersection of the 2 perpendicular bisectors, this must be equidistant from A and B because it lies on the first perpendicular bisector, but also equidistant from B and C because it lies on the second perpendicular bisector. So basically what this means, at this point, let's call it O, is equidistant from all the 3 points A, B and C. So it's at the same distance from A and B and it's at the same distance from B and C. So this is how you locate the point that is equidistant from all the 3 points. You complete any 2 segments. So here we drew AB and BC and then you draw the perpendicular bisectors. So we drew this first perpendicular bisector and the second perpendicular bisector, and then we took their point of intersection, and that point is equidistant from all the 3 points A, B and C. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.